Hello and welcome back to the lab. Back on the bench today, we have the HP Model 400D Vacuum Tube Voltmeter that I was working on for the past month or so. Um, this is the second one, the one that I plan to fully restore and then give away to one of my lucky viewers who would be so interested. Uh, when we left off, I had replaced the power cord that was frayed and kind of worn and cracked and brittle in a couple of spots. Um, I had cleaned it up thoroughly inside and out, removed all the stickers and so forth that were all over it. Um, I noticed that it had the incorrect fuse in the rear panel, so I replaced that with the correct fuse. But in doing that, I realized that if there was the incorrect fuse in it, then that means that the fuse had been replaced at one time or another with the wrong one, and that means there was probably something going on with the fuse that it was blowing fuses. Um, I plugged it in and turned it on, and it blew the new fuse immediately. So that's pretty much where we left off. I noticed that it had some electrolytic capacitors in here that were in bad shape, and so we're going to continue working on the HP 400D vacuum tube voltmeter today, and I do still intend to fully restore this instrument and then give it away because I already have one that's working and I don't need two of them. So I'm going to work on this one and get it going, and then we will give it away to someone, and we'll find out how to do that later on when I'm finished with that. All right, so let's get started. So I went through and I tested each section of each capacitor of these can style capacitors, these electrolytics, to see which ones had failed. And I found that a couple of them had failed. And I made myself a little chart so I wouldn't lose track of what I had found. I found that actually um, one section of C1A was open and leaking electrolyte. I found that one section of C30, even though it tested okay, it was leaking electrolyte, but it's tested okay. So even though it tests okay, it is leaking, and therefore I'm going to have to replace that one as well. I found that one section of C105 was open, so I'm going to have to replace that one as well. C39 tested good, C17 tested good. So I have three defective CAN electrolytic capacitors. That means there are at least, let's see, 10 new electrolytics I'm going to have to put in there to replace those three defective cans. And I might even consider replacing the others that actually test still good, because while I'm here changing them, I might as well change them all and just get it over with. Obviously, something seriously went wrong with this instrument for that many capacitors to fail. So I wanted to show you on the schematic um, where the failed capacitors are located in the circuit. The first capacitor that I found that was bad is C1A, and that capacitor is located right here. It's part of the bypass circuitry for the biasing circuit for V1, and that capacitor C1A was open. Um, that there should be a positive voltage on this grid, but it should still be more negative than the cathode. This is configured as a cathode follower. V1 is configured as a cathode follower. So um, I wanted to make sure that this resistor R1 was not also open, which it was not. If that was open, we would have the full B plus voltage on the grid of the tube, which would, destroy the tube and maybe other parts of the circuit as well. But R1 is not open, so we probably have the correct voltage at this point, but there is no bypass capacitor because that cap was open and it was also leaking electrolyte. The next capacitor we found that was bad is C30D. C30D, I believe, well, C30D is one of the main filter caps directly off the rectifier tube, one of the high voltage rectifier filter caps. It tested okay. It's in parallel with C30C, so a total of 20 plus 20 or 40 microfarad for filtering the main B plus voltage, the unregulated side of the B plus voltage. This cap actually tested okay, but it was leaking electrolyte, so we're going to have to replace that. The next one that we found that was bad was C105A, and we found that that one was open as well. C105A is, well, let's see, right here. It is the cathode bypass capacitor for V3, and if that capacitor is open, we're not going to have any AC gain through V3, so that's certainly not going to work properly. It's also configured with a 2.7 ohm resistor, which I checked, and that resistor is fine. So this capacitor is open, so we have to replace that one as well. So those are the three capacitors that we found that were failed in this circuit. Now, there are two types of CAN electrolytics in this instrument. One of them is a 4-section, and each section is 20 microfarad at 450 volts. To replace those sections of those types of caps, I have these 22 microfarad at 450 volt electrolytics that I can use. Each one of these will be one of the sections, those 4-section caps. The other type of cap is a low voltage cap. It's 1500 microfarad at 15 volts with 2 sections. Each section is 1500 microfarad at 15 volts. I have these 1500 microfarad at 35 volt single section caps to replace those. I have 2 different ways I can go about replacing them. I have some of these terminal strips, these standoffs, that I could stick in there and use them to install the replacement caps, and leave the existing CAN capacitors in place, just disconnect them from the circuit. That's one option. The other option is this. I recently bought some of these little plates that you're supposed to be able to insert your electrolytics into them, and you can fit 4 sections in the little plate, and the little plate can replace the entire 4-section CAN capacitor, and the new electrolytics will stick up through the chassis onto the other side of the chassis. I thought that would be a great solution. These are really well made, well designed, and a perfect solution to replacing these old multi-section CAN caps. The problem is these plates are a little bit larger than the spacing on this plate is a little bit larger than the holes for the existing caps, and I would have to open those holes up somehow with a Dremel tool or a file or a chassis punch or something. And I don't really want to do any alterations or modifications to the chassis of this instrument, so I probably cannot use these without doing that. So I'll have to save these for a different project. Now, I did buy enough of these replacement caps to change out all of them. Plus, I have a few more than that, a few extras. And I don't usually like replacing components that are not defective. I like to only change out parts that are defective. But in this instance, because I found so many defective parts, I'm thinking I might want to just change out all the electrolytics and and be assured that we have all good functioning modern capacitors in this instrument. That's probably what I'll end up doing. Let's get started on that now. Well, here's what I came up with. I decided to remove the can altogether and attach a little terminal strip in the vicinity of the opening where the can was located, and mount the electrolytics on that terminal strip, facing in the same direction that the original can capacitors were facing, on that side, on the tube side of the chassis. There really wasn't a lot of room on the underneath side of the chassis to fit these electrolytics in there. Um, and I'm feeding the wires through the opening where the can was located back into the circuit where they are connected back to the original connections. So I've completed one of those circuits, and I'm going to now continue and do the rest of the cans the same way. It's not really the most attractive solution, but it's really the only thing that I could do. I had to drill just one hole for a mounting screw, and so there was a minimum of um, alteration to the chassis. This should work. Okay, so as you can see, I've replaced the dual 1500 microfarad cans with these individual electrolytics on terminal strips. And these are the cans that I pulled out of the instrument to replace. Um, I decided that I wasn't really going to be happy replacing all these capacitors with individual electrolytics on terminal strips like we have here for these low voltage 1500 microfarad uh, sets. Um, these other ones that are the 20 microfarad times four individual caps inside a can. It would be too difficult to really get all those electrolytics lined up on a terminal strip and get it to all fit in here properly. So I decided that because I still do need to replace all these electrolytic cans, I decided to break down and go to to Hayseed Hamfest and have custom made electrolytic cans made specifically for the 400D. So inside of this can is four 20 microfarad electrolytic capacitors. They're sealed up inside the can, and it's a direct fit, direct replacement for the four electrolytics in one can that came out of here. These cans, I think, are from 1968 or something like that, and these are from 2024. Um, they're high quality capacitors, very nice, very nice. It's the first time I've used these. Um, they're 105 degrees C, 20 microfarad, 450 volts times 4. It's a direct drop-in replacement for the old electrolytic cans. Rather expensive, but the quality is very good, and I'm sure I will use these people again. Hayseed Amfest, not sponsored, by the way. I paid full price for these. They were quite expensive, but they will look great in there, and they'll work perfectly. So that's what I'm going to do. All right, so I have good news and I have bad news. First, the good news. I have completed the recapping of this instrument. Um, I replaced all three of these can caps, the 4 by 20 microfarad, with these gorgeous custom made Hayseed Hamfest can capacitors. For the low voltage 1500 microfarad dual caps, I have put in modern replacements on terminal strips. I've also replaced this one, which was a 500 microfarad, which is directly across the meter movement. Um, it tested good, but it showed signs of having some leakage of the electrolyte out of the positive end of the cap. So I replaced it as well. So that's the good news. The bad news, of course, is just as I suspected, changing out caps that are open is not going to stop it from blowing fuses. There must be something else currently wrong with it. And in fact, I did plug it in with a new fuse and it immediately blew the fuse again. I double checked all my wiring and I didn't make any wiring errors. So the original problem still exists in this instrument. I have a feeling there may be a problem inside the main power transformer. I am not sure. I thought I checked it and it seemed like it was okay, but I may have missed something. I must have missed something because it still blows fuses. So my next course of action is to compare this instrument um, with one that's actually working. I have the other one that I'm going to keep. This is the one I wanted to give away once I get it repaired. I'm not so sure I can get it repaired now, but we're still going to work on it. So what I'm going to do is do some A versus B measurements to compare the power transformer and the associated wiring on the primary of that power transformer to see what's different between this one and the one that's functional. And maybe we will find the problem. I'm hoping that it's not this expensive power transformer. In fact, impossible to obtain power transformer. Um, but I have a feeling it may be. But some further investigation is necessary. So I wanted to introduce you to our new lab manager. This is Hopper. He is a 3-month-old stray kitten, which we took in about 2 weeks ago, and she's going to be running things around here from now on. I'm allergic to kitties, but this particular one is so cute that I decided to just take allergy pills, and so this is our new lab manager here. Say hello to Hopper. Well, I am fully committed to completing the repair and restoration of the HP 400D vacuum tube voltmeter, and I also still plan to give it away to one of my viewers who would like to own this fine vintage piece of test equipment. But that will have to wait for the next third installment of this series on the repair of the HP 400D. Please stay tuned for that. Thanks for watching. Please like and subscribe, and I'll see you on the next video.